Okay, in regular chemistry, we're going to continue on in chapter 4, and we're going to talk about the structure of the atom, atomic number, atomic mass, and how to write different forms of isotopic notation. Hopefully you have your periodic table in front of you as we go through this section. Okay, so the structure. So the nucleus of an atom will contain the protons and neutrons. And a lot of times people do not want to write out the word proton and neutron, so we can write proton P with a superscript positive since it has a positive charge, and a neutron an N with a superscript 0 since it has no charge. And it contains most of the mass of the atom. And that is because we assign protons and neutrons each in a value of 1 AMU, and we say electrons have no mass. That's not their true mass. There's a table in your book that will give their actual mass. Outside the nucleus, you find the orbitals, so the orbitals will surround the nucleus, and they will contain electrons. Electrons have a negative charge, so oftentimes we'll write them E with a superscript negative to indicate the negative charge, which basically have no mass. Okay. Next, the atomic number. The atomic number will tell you the number of protons that an element contains. And so when you're looking at your periodic table, the atomic number is in the upper middle of the box or the upper right-hand corner. I think for the one you have, it's probably in the upper middle. It determines the identity of the element. Since atoms are electrically neutral, so that means for every positive charge they have a negative charge, you can also tell the number of electrons. So keep in mind that atomic number specifically tells you number of protons, but you can figure out the number of electrons. So the first question says, what is the atomic number of aluminum? So you simply find aluminum on your table. And after you've used your table for a while, you'll be able to find these quickly. So aluminum is over here, it's right below boron. So it's element number 13. So it has atomic number of 13. If it would have said what's its number of protons, then that's the same as the atomic number. That would be 13. Then its next question is, which element has 26 protons? So you find element 26. And it's down here in the transition metals. It's Fe. Fe is the Latin name ferrous, or it's ferrous in Latin, and it's for iron. So which element has 26 protons would be iron. Okay, put me on pause for a second, and then you answer the next few. Okay, so the next question is, how many protons does a neon atom have? So you get your periodic table, go over to the noble gases, and neon has 10 for its atomic number, so it would have 10 protons. And then how many electrons does a neon atom have? Well, it has the same number of electrons as it does protons, so it is 10 electrons. The next question, an element with an atomic number 6 has how many electrons? Well, if it has an atomic number of 6, that means it has 6 protons. If it has 6 protons, it will have 6 electrons because it's electrically neutral. Pretty simple stuff. Okay, atomic mass is our next topic. Atomic mass is the number of protons and the number of neutrons. So you simply add up your protons and your neutrons, and you get the atomic mass of that particular atom that you're talking about, of the element. So here is one of our notations. We'll talk more about it in a second. It's oxygen -18. It has a mass number of 18. How many protons, neutrons, and electrons does it have? So we simply find oxygen on the table. It has the atomic number of 8, so that means it has 8 protons. We already know if it has 8 protons, it will have 8 electrons. And then it says how many neutrons. Well, if 18 is its mass, and protons and neutrons equal mass, you can simply take 18 minus 8 for your number of protons, and that leaves you 10 neutrons. So neutrons and protons has to equal your mass. If a particular atom of carbon has a mass of 14, how many neutrons does it have? So if your mass is 14, you look up carbon on the table. It has an atomic number of 6. That means it has 6 protons. So you take 14 minus 6, and it would have 8 neutrons. Now, almost every element on the table has isotopes, which are atoms of that element, and they can have different numbers of neutrons. So they will have varying masses. However, isotopes of an element behave the same. So their chemical behavior is not different. Okay, so here's our first example. Hydrogen has 3 isotopes, and we want to figure out how many protons, electrons, and neutrons and the atomic mass. And they gave hydrogen isotopes names: protium, deuterium, and tritium. Since these are hydrogen, when you look up hydrogen on the table, hydrogen has an atomic number of 1, so that means it has 1 proton. If it has 1 proton, it's going to have 1 electron. So each of these isotopes has 1 for its proton, 1 for its electron. Now, I'm going to do this kind of backwards. Tri means 3, so tritium has an atomic mass of 3. If you're in a duet, there's 2, so deuterium has a mass of 2. And so there's a pattern, so protium would have a mass of 1. Okay, to find the mass of the number of neutrons, remember you take your atomic mass minus your protons, and that gives you your neutrons. So put me on pause for a second and you figure out the number of neutrons. Okay, so hopefully you said that protium has 0 neutrons. Deuterium has 1 neutron because 1 plus 1 is 2. And tritium has 2 neutrons because 2 neutrons plus 1 proton gives you 3. Now, thank goodness most of the elements on the table do not have names for the isotopes. Instead, we use 2 methods to designate the isotope that we're talking about. So one is called hyphen notation. And hyphen notation, the mass number is added with a hyphen to the name of the element. So I gave you 2 examples already. So you have uranium hyphen 235 and uranium hyphen 237. So if you were reading a chemical journal and you came across this, then you would realize this is an isotope of uranium with a mass of 235. The next method tells you a lot more information, and it's called nuclear symbol. Method or notation. I think your book might call it isotope notation. Okay. And here is how you do it. So you take the atomic number and you add it to the symbol for the element as a subscript on the left of the symbol, and the mass number is added as a superscript on the left. So for this first one, you find uranium on your table. Uranium symbol is U. So you put U. We're going to use this one here. We're going to use the same mass. So the mass is 235. And then you look up uranium's atomic number is 92, and it goes as a subscript. Okay. Now put me on pause and you do uranium hyphen 237 doing nuclear symbol notation. Okay. So hopefully you said uranium 237, 92. Now, if you were reading some chemical, in a chemical journal and you came across this, you could go, oh, this is a uranium isotope. It has a mass of 235. It has an atomic number of 92. Since it has an atomic number of 92, it has 92 protons. Since it has 92 protons, it also has 92 electrons. And if you had a calculator, if you were good at math, you would just say 235 minus 92, and then it would have 143 neutrons. So this notation gives you a lot more information. Okay, that finishes our topics for today. And so on your study guide, you went through 4 the other day, so now you will do 5 through 20. Thank you.